All right, what is this, Lady Ada?
Hey, welcome to the on-air hangout as seen on Show and Tell. That's what we're doing here. It's me, Lady Ada, at the Adafruit Factory. Happy birthday, United States of America.
America Day.
It's America Day. There's everyone loves that. There's fireworks and hot dogs. Yeah. Me and Mr. Lady Ada are hanging out at the factory. We did electronics today. We love to do.
Yep.
But right now we're going to hang out with all the folks in the community for the next half an hour. We're going to do a show and tell. People from around the world are going to show up and show off their projects. We're here till 7:50. Take a couple minutes, show off your project. Maybe more people will show up. And let's start off with Phil B. and then Chris Young and then everybody else.
Yep. Phil B, what you got?
Okay. I have, this has become like the project that will not die is this eyeball code. This originally ran on the Teensy 3.1, 3.2. But, the M0 and M4 chips we have on some of the boards are pretty beefy. And I was able to get it to work pretty decent performance using DMA. In fact, this one's running on a Teensy M0, which is kind of just ridiculous how tiny it is. So this has all been merged in with the, if you go to the Teensy project that's in the learning system, the code now will work if you're using like a Feather M0, M4, a Metro, itsy bitsy. Bit of a struggle to get it on the trinket because of the pins. But on some of these other boards, it runs just great. So, freedom of choice there with what kind of hardware you want to use.
That looks great. And that's our 128 by 128. If you want the 240 by 240, maybe the Feather M4 would be able to do it.
Yeah, I haven't adapted the code to do that, but yeah, M4 might be able to handle that. If not, we got the Pi project for doing.
All right, that's cool. Everyone always loves spooky eyes.
Eyeballs, yep.
It's basically Halloween already, right? Right after July 4th.
On my planet, every day is Halloween.
We're pretty much it's Halloween season. Okay, thanks, Phil B. So check that out on the GitHubs.
Okay, next up. Chris,
hey, Chris Young.
How's it going?
Can you hear me?
Yep.
Can you hear me?
Yep.
Okay. This is a project I've been wanting to do for a long time. As you can see, it's a 60 element neopixel ring. And the minute that I saw that you put that out in the store, I don't know how long ago it was, I said, well, you must have made it so that people could make a clock out of it. 60 dots and a circle, perfect for a clock. Nobody's ever done it, or if they have, there's no learning guide for it. So I started working on it. And if you use a SAMD21, this is running off a Feather M0, it has a built-in real-time clock module. So of course, but once you set it, it keeps real time for you really easy. And Arduino has a RTC0 that they put out for the Arduino manage the real-time clock really easily. If you look the blue segment, now I think it's reversed. I think you got a mirror version of it there. But it doesn't look like the green dot's going counterclockwise.
Yeah, it's correct for us.
Yep.
Yeah. Okay, well, it's mirrored. I'm sorry. But anyway, the blue section is the hours. The little red dots are the minutes, and the green dots are the seconds. And I thought, well, I should make it chime on the hour. So I hooked up a little buzzer speaker, and it didn't sound very good. So I got a music maker shield, or feather wing, and to make it chime. And I thought, well, wait a minute. If this thing can play MP3 files, it can play anything. So why not record some voice information? So if I hit a button on my infrared remote.
The current time is 7:35 p.m.
Can you hear that okay?
Wow. That sounds great. That's a great voice.
It's actually, my Dragon Naturally Speaking has a readback feature where you type out a message and say, read that, and it reads it in that voice. And so I just recorded that and converted it into MP3 files. Now, I'm going to fast forward it here to show you the chimes.
37.
I'm hitting buttons
38,
on my remote.
39.
It's advancing the minutes.
40. 41. 42. 43. 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59.
Now I'm gonna
Okay.
make it jump. Here we go.
There you go.
Oh, yeah.
Little Westminster chimes out of Big Ben.
That's nice.
I found these files online, and I asked the website if they were copyrighted or not, and I haven't heard back from them. But I do have a MIDI file that I can turn into an MP3 when I actually get ready to release this, if they won't let me use their MP3 files. So then I said, okay, we need a setup menu. But how do you create a menu when you don't have a display? Well, you make an audio menu. So I'm going to hit a button to put it into setup mode.
The current time is 8
Oh,
p.m.
well, I had to finish that. Okay, here we go.
Entering setup mode. Press up or down to change each item, or press right arrow to continue to next item.
That's
Audio mode is currently continuous.
So I can do continuous, I can do mute, I can do time-based so that it goes quiet at night. Or it's also got a photo sensor that, and when it's at dark, it would go quiet.
Daytime. Volume
And
level.
I can change the volume levels.
Chimes enabled.
I can turn the chimes off and on. Here, I'll turn them off and on here.
Chimes disabled.
There, I turned them off.
Voice enabled. Animation mode is currently disabled.
Eventually, it's going to play an animation at the end of every hour. I haven't done that yet.
Hourly enabled.
Do you want the chime on the hour?
Quarterly
Do you want
enabled.
quarterly chimes?
Setup completed.
And then when you're done, it says setup completed. So I didn't really start out to make this an assistive technology project. It was just supposed to be a cool little clock. But I got to thinking, this is a talking clock. You
Yeah.
know, what if you were visually impaired or blind, or what any other kind of project that you have that doesn't have a display on it, but you want to be able to set menu options, put a sound card on it, and do audio menus. So I'm going to write all this up in a learning guide eventually. It's going to have a 3D printed case, and it'll be a really nice learning guide. But right now, it's a work in progress.
This is really great, Chris.
That's amazing.
Just generally speaking, having the audio prompts for interfaces when we were doing our Cricut robotic projects, because you don't use a keyboard or a monitor or anything, it gives you voice prompts and tells you the buttons that it's pressing, the mode that it's in. That's just good user interface. Great work, Chris.
Yeah, great.
The only disappointment I had was, I use infrared, but not everybody's very good at that. I wanted to make it do Bluetooth,
Yeah.
but unfortunately, your Bluetooth and your music maker wing don't get along. And you might want to put a note on that on the product page. It says so in the learning guide, but the product page doesn't mention it. And I don't know what the incompatibility is.
I don't know why not either. I can't remember, but it's been a while.
Yeah.
Okay.
Drop us, we'll double check it.
They
Yeah.
both use SPI, but the Bluetooth on the M0 uses all internal pins. It doesn't use any of the broken out pins.
Yeah.
But I verified I can't get it to work together. So,
All right.
Yeah,
something to
drop
look
us-
into.
it-
All right,
it-
I'll let you know when I get it done and write up a learning guide.
Okay. Thanks so much, Chris.
Thanks, Chris.
Timely project. All right, I'm gonna go to Noah and Pedro because I know they're gonna launch a firework, and then we'll keep going. I know what's about to happen. All right,
Hey,
Noah and Pedro, I know you want to do this. Go for it.
you're outside. Wait.
Oh wait.
Oh,
Okay, now you're back. All right.
Hey guys.
Okay.
All right, go ahead. Go for it. Happy
Let's do
Fourth.
this thing.
Yeah.
Yeah, it's all rainy here, but we're gonna set off fireworks anyway. Yeah, we got our nice little chair here. Yeah, so this week's project is this really cool button inspired by the Nintendo Labo. We rebuilt it, put it up on our Learn guide, and then we have down here, we're heating up some Kenthal wire. So you want to go up there. We got some Sparky themed fireworks. So all it's doing is just taking two 9 volts, and when you push down on the button, it just heats up the wire. You can barely see right there. It's just over top of the fuse. So let's go ahead and light it off.
Yep.
All right, might have to back up. Oh, I was gonna show the button actually working.
Press the button.
All right, let's press the button.
The cardboard button. Oh, here we go. Okay,
Oh,
so
good.
In
press
the
the
rain,
button.
right?
You press and hold.
There
Oh,
Yeah.
there we go.
Whoa. All right, stay safe.
Well, they're in Florida.
Back up a little
Everything's
bit.
okay in
It's just a
Florida.
I
fountain.
think they're like dragging
What we
away
had
the
to
right
try
thing.
before is actually sticking 2 of the fuses together. Let's see if they go off at the same time. Double the sparking! Woo! Yeah!
Wow.
Yeah!
This is all live. They really did this.
Go America. Wait, they got muted by accident.
This is great.
Looks cool though. Wow, look at those fireworks. They last quite a while.
All right, Noah and Pedro, I don't know if you can hear us, but you went on mute. So we're going to keep moving because I have a feeling that fireworks going to last a while.
Yeah. Okay, cool. All right.
Outstanding.
Come back.
Great
if you
live
come
demo.
back.
Oh, there it is. Yay!
Yeah, you can get all the files to turn your own fireworks into some Sparky themed ones. It's all available on learn.adafruit.com. You can get all the files to make all the graphics for this, and of course, do the cutouts to make your own push button box. Check
I
it
can
out.
say for sure this was the only live cardboard launching fireworks
In the rain.
right
yeah.
right now. All right.
All right, good work.
Thanks, guys.
Okay.
Happy 4th. Happy 4th.
Go to- Hello. Hey, Gavin. All right, we're going to go to Remen, and then we'll go to Dave, and then we'll go to Mark, and then we'll wrap up with C. Scott. So, okay, Remen, how's it going?
Hey, women.
Hey, call me Ray. That's
Ray.
first. I'm from the Netherlands, 24 years old, and I've actually saw in a video from Lady Ada where she disassembled the Elgato Stream Deck.
That's right.
Yeah.
This little thing. Well, that prompted me to, kind of be on this show and tell bit. I've been busy writing alternative software since I do not agree with the software as it is right now.
I use it. I don't agree with it all the time either.
Yeah, thank you. Well, basically, I'm a software developer at heart, not a streamer at all, and I wanted to use it for my development environments, so I could actually use the Stream Deck to launch certain actions within my IDE. As for the progress of my project, I'm not too far yet. I've been actually busy writing the software itself in C++ with 0MQ and other interesting technologies, and writing the front end in Qt5. If I can figure out how to stream my goddamn desktop, I can.
One day you'll have a keyboard that will
They'll
help
let you do
it.
that.
Yeah.
You should look at the Stream Decks up. You need another Stream Deck to stream your Stream Deck.
So, how does one stream the desktop again?
There's a little button up at the top.
Like share desktop, maybe.
You have to mouse over your window, and on the menu will come up on the side. It's a little green button with an arrow.
Ah, yeah, thanks.
Yeah, screen share.
Let's do it. Here we go. Hey.
Hi.
Hello.
Okay, so at first, we've got the software right here. It's in command line. I cannot really show anything that could probably be readable, but I will press a few buttons right now.
Ooh.
Okay, you got something
Messages.
going on.
You're reading things.
Yeah, event publish, key 363 down.
Yep.
Yeah, you got going. So this is just right now. You're getting this.
I'm getting the events from the Stream Deck already, and I'm actually setting them over a ZMQ socket and receiving them right here in another application that I've already started.
Okay.
In the background. That actually receives the key presses from a 0MQ socket, and that in turn allows other people to integrate their stuff into this software.
This is great. A lot of people have these. Send it when you have code, or if you want us to blog about it, because more people might join in through the contact form on the blog.
I've actually already sent a message with a link to my blog. This is the front end, the graphical part of my software that I'm working on. And as far as it goes, I've got the buttons down, but when you press another button, yeah, well, that shouldn't happen.
Well, it's in progress. Come back when you've got it working even more. We'd like
and
to
if
see.
you want a show and tell sticker either digitally or virtually, or sorry, physically, email support at Adafruit and we'll send you out one.
Okay, thank you very much.
Thank you, Ray.
Keep coming
It
back.
was great being on Show and Tell.
Yeah,
Yeah,
keep coming back. This is a really good project. We'll switch
Thank
over
you.
to your software after.
Oh, yeah,
after you're
totally.
done.
We're going to totally switch
Yeah.
over.
All right. Next up, we're going to go Dave, then Mark, and then C. Scott. Okay, Dave.
Hey, Dave.
Hey. Nice. It's been a while since I've been on here. I wanted to show the project I did for the most recent guide that got published, I think, on Monday.
Mhm.
So let me switch. Using multiple cameras, too, which is new. There we go.
Ooh, nice.
Okay. So let me make it so I can actually see it on screen. This is a Pomodoro timer. So it's to help you focus on work and then take a break regularly as well. So it's itsy bitsy M0 based. There's a NeoPixel ring and a rotary encoder, and inside there's also a piezo buzzer driven by the Pulse IO library. Partly this was an excuse to play with the new rotary IO support in CircuitPython. This is all done in CircuitPython. So we switch it on, and we see the timer every second. It blinks.
You want to switch to your other camera, Dave? Because we're on you.
Let's switch back.
Okay.
There you go.
Oh, I know what I did. There. That should save. Okay. Yeah, so it blinks once a second and gradually counts down. To set it, you use the switch on the rotary encoder, use the dial to set. Each one of these for work mode is 10 minutes worth. And I'm going to set that right down to 0, so we'll hear the buzzer, hopefully. Press it again. You go to set how long your break is in between work sessions, and then press again to go back to active mode. And I'll get close, so maybe you can hear the buzzer.
Oh, yeah.
Oh, yeah.
Right, and then it starts timing. And that's it. So yeah, itsy bitsy 3D printed case. So there's USB to charge it with or to load code. Little slide switch on the side. Mount for the rotary encoder. Little hole for the buzzer. And I recessed a ring to hold the NeoPixel ring. So it was a neat little 3D design project as well. It's funny, the hardware and code took about a day to build and put together, and it took another 4 days to iterate on the case.
Yeah, that's how it goes.
But it turned out well.
Just make sure you take breaks in between that.
I have a way to make sure I do now. So.
All right. Thanks so much, Dave.
Right, Dave. And we got some more guides coming from you soon, so everyone keep your eyes open.
Okay, we're going to go Mark next, and then we're going to...
I have a way to make sure I do now. So.
Okay. Hey, Mark.
And we got some more guides.
I think Michael,
okay.
yeah, mute Michael. Okay. Okay, Mark.
All right, microphone works?
Yeah. Yeah.
All right. I don't have my camera. I'll just keep it easy and keep on the screencast. Hopefully it will work well enough. So I had some NeoPixels I got from you a while ago, which I use for strips for my shirt and pants. And then I realized, well, we can do something better than just that. So of course, you guys know about the great NeoMatrix library that you have, which I wrote a few demos for. And I realized, well, of course, that should totally go on my shirt. So instead of having about 200 pixels, I have about 1,700 now. Mm-hmm. I'm sure you know about Fast LED, which does a few more things than just your simple NeoPixel library. Yeah. And basically, that's just a regular matrix, right? 16 by 16. And then when you have more, you start going into timing issues because it takes too long to update. So this is what the panel on my shirt looks like from the rear. It's 3 different panels of 8 times 32. And I have basically 3 data lines going to each panels. So I can drive all 3 at the same time and get 3 times the refresh rate. Of course, that's not supported by the basic NeoPixel library. So for that, I have to use the Fast LED library. And I ported your NeoMatrix library to Fast LED, so I can use the same code that I had plus extra things. So if you can see, the blue cables are those are Cat5 cables for twisted pair that are going into that little green board on the corner. That's an ESP8266, which is then driving the 3 data lines at the same time. You can see the big batteries on the side. As you know, NeoPixels are hungry. So I have about 10 amp hours and 16 volts to run that for about 10 to 12 hours, which hopefully I'm not going to any place where night lasts more than 12 hours. That's my plan for now. And let's see, instead of doing a crazy demo live, I'm just going to show you a couple of videos. But that's the rear of the shirt, where basically the NeoPixel a panel is embedded inside the shirt. So it's using the shirt as a diffuser. So it looks like this, which is kind of nice, actually. And then the front is actually the other panel, which is Velcroed onto the front. On the side, you can see the two NeoPixel strips, which are actually running your code, the nice demo code that you give with the NeoPixel library. So that shows you a few things that can be displayed, shows you the back of the shirt, doing the same thing. And then I can show you a little bit what it looks like. So I don't know how well video is going to work. Let's see.
Yeah,
is the refresh rate okay at all, or?
Yeah, we're getting a few frames.
Right. So that gives you an idea. I'm going to scroll through some probably like, yeah, that's actually not super fast. It has to reload. Okay. That's not going to be great. So let me switch to that other one down there. Hopefully that. Since it's July 4th, I actually have fireworks on this shirt. If it will load for us, let me try it.
Yeah.
Oh yeah.
And so I spent way too long finding some existing code, existing demos, and writing my own to use that that panel. This actually looks pretty cool at night. People just stare into me when I see that little scrolling thing. And let's see, so of course any matrix, if you can just show pixels, that's easy. But the reason of porting you use Adafruit GFX, of course, which was the text that you were seeing there. So that's actually using just the Adafruit GFX library, and I can reuse your fonts and then just display without having to do my own code for that. And I think I have another one that's showing font zoom, like this one. Actually, rewind a little bit.
That's cool.
Let's see if YouTube is going to play game. There we go. So this actually, I've pre-computed the font that you provide at multiple sizes. And then I'm just displaying those sizes to show a zoom effect that I don't have to do real time, because otherwise it would be way too slow.
Yeah,
looks great.
So that's pretty much what it looks like. You can get so much code out there that I was able to leverage, so I didn't have to write everything myself. That's usually a lazy programmer is a good programmer. And then, of course, you can see the same thing running in the back. So that was, I used that first at EDC, the Electronic Music Festival in Las Vegas, about 140,000 people. And of course, Burning Man is next.
All right. Well, email supported.
So, that was the demo.
And we'll send you an asset on the show and tell sticker. And if you want the digital assets, you can just email me, pt@adafruit.com, and I'll send that to you. And you can
render it on your shirt.
You can show Asine on the show and tell.
That's easy.
Sure.
All right.
We're going
that sounds good.
Michael, and then see Scott. Michael, if you can keep it pretty fast, we can get to you and see Scott. Take it away, Michael.
Hi, it's Michael. I think I'm having some trouble with my video, so I'm going to just transfer over to a screen share here. I think you can see my little clock that I've made here project.
Oh, yeah. 2 clocks tonight.
Two round clocks.
Oh, yeah. This is kind of an exciting one. That it says the time, the seconds around the outside, the date on the bottom, temperature and humidity it's getting from MQTT. And this 80,944,073, it's a little less now, is the number of seconds until 12 noon on January 20th, 2021 Eastern time, counting down the number of seconds till that moment.
Okay, wow.
What's happening then?
It's the next scheduled presidential inauguration.
Okay.
You better get tickets.
Yeah.
All right, this is a cool clock. I mean, you can put in anything you want. We made a clock that counts down seconds till you die.
I love countdown clocks, since people are like, "Hey, what's that?" And then you get to say, "Oh, well, here's what it is." Like, "Oh, wow, I didn't realize."
It'd be great to be able to use the Adafruit IO library with this. I'm using the kind of the older MQTT library. Is there any way to get the time with the new Adafruit IO?
Yeah, you know what? Drop me a note, pt@adafruit.com, and we can make sure that can happen because we support all that.
Good timing. We're actually doing some work on that library right now and doing some updates. This is if we may have just forgotten to document it or put it in, we'll just do that super easy.
And also email support at Adafruit for a SE on the show and tell sticker.
Thanks so much.
It'll be there in a matter of seconds. I don't have a clock.
And this clock has so much.
See, Scott, play us out.
Yep.
Hey guys, okay, I wanted to talk a little bit today about we are about to have some tariffs imposed on equipment and parts coming in from China, and I wanted to explain a little bit about what that means, because I'm going to link an article real quick into the Discord chat under live chat. This is a list of what is affected. And what concerns us most is probably page 46, where they say resistors of all types, capacitors of all types, and so on. But here's the thing. It means, like, you know, for resistors, if you have your reel of 5,000 resistors, you're going to see about $14 more. You know, capacitors are up in the air. It's going to be nominally about the same. But capacitors right now are in a bit of a supply chain issue because everybody panic bought them like a couple months back down to zero inventory, and it's been difficult to get various kinds of caps. But again, it's not a big deal. So, you know, you take a capacitor that costs 3 10,000ths of a cent, and all of a sudden it costs 2 10,000ths of a cent. You know, it may affect your $100 retail price by, you know, if you use 20 caps, and it may be $4. Anyway, moving on, you know, the thing that should not happen is a product is all of a sudden advertised as being 25% more expensive because of his tariffs. No, that's not the way this should work, because the actual stuff that's affected, and moving on here, you know, one of the things, this all started with an article that Moog Music published. And
we got that one too. They said, you know, this is not ideal for them.
I linked the wrong one. Here, let me get the correct one. Here we go. I thought I did that. Select.
Also depends what you're making, like motors. If you have anything with robotics, motors are on that list, and like it's all motors, and those are expensive. So a 25% increase, it is a couple bucks.
There. Now, anyway, I'm not sure how much due diligence they did, but I think what is concerning them is if you look on page 56 of the document, this is called paragraph 90, heading 30. And so the number is like 90309068. And the line item is printed circuit assemblies, NESOI. And the key term here is NESOI, which means not elsewhere specified or included. Now, this is the ITC, that's the International Trade Commission, has these shorthand codes when they don't want to formally show all of the exact details of a subchapter. Subchapter is like everything on that page, 9030 subchapter number. You need to like have a degree in understanding how ITC shipping codes work, but I've just messed with them enough. I know a little bit about it. But if you search the PDF for printed circuit assemblies, you'll see a lot of hits on like ATM machines and radiation detectors and stuff. But the issue here that people should not be worried about, and I think Moog might be, is that these codes are an abbreviated description, and they're not really formally written in the actual codes, which means that like chapter 90 is specifically talking about oscilloscopes, and that 90309068 is referring to a non-US company importing a kit of parts into the USA and then including a stuffed TC board and then building a scope in the USA. Well, this is basically written to protect like Tektronix or Agilent.
We have to get out of here because it's 8 o'clock. So do you want to
continue this next week? Because I
know there's a lot of details.
But you know what? Because we'll keep going just one more minute. What in closing though, what advice do you have? Should people be panicking? There's no more electronics. Everything's gonna be 25%, or
do not panic, because 99% of what is affected is not going to hit the maker community. The worst you're going to see is your 10-cent capacitor will be 12 cents.
The current time is
if you can find a capacitor right now, because everybody bought the pipeline down to zero.
That's good advice. Yeah, we've been like we always are ready for supply chain changes, from locations to adapting prices, building in margins. So like we're not panicking yet at all. We said that, like, we just roll, like that's how you have to be. It's out of your control anyways. But we're gonna just keep staying active as we see stuff. We're gonna of course let everyone know, like, oh, this is now more expensive, or this didn't matter, this didn't change, and here's some ideas.
The one bullet we did dodge is not listed on the tariff document is bare circuit boards. That would have been a bit of a problem because all of a sudden you'd be paying 25% for their PC board, and that can affect a lot of businesses' bottom lines. Yeah. So yeah, we're safe there. But I know you guys got to get going. Next week, I'll tell you about freight forwarding, which is like the supply chain logistic bugaboo that's now being raised because of the tariffs. But yeah, that's it for me.
Okay. Whew. Well, thank you so much. And the theme is don't panic. Thank you.
Don't panic.
All right.
All right. Thanks everybody.
That's the show until this week. Thank you, Ray. Thank you, Phil B. Thank you, Noam Pedro. Thank you, Mike. Thank you, Mark. Thank you, Dave. Thank you, C. Scott. And thank you, Chris Young. We're here every single week.
Current time is 8:01 p.m.
Yeah, exactly.
Exactly.
And
let's play this out.
We'll see everybody next week. And thanks for making this a fantastic 4th of July. What better way to celebrate Independence Day than coming together and showing the stuff we make? Yay, America.
Yay, fireworks and fireworks shirts.
We'll see you on Ask an Engineer in just a few minutes. Bye-bye.
Bye.